Hello, hiya. Welcome Sarah and welcome Claire as well. Welcome to this latest lecture in the A Star series. So what we're going to do today, we are going to focus on well, the topic officially is graphs. It's probably more accurate actually for what we'll do. Um, with graphs and charts as well, as we don't have a separate lecture for charts. And it's one of these topics, this one, where it's very wide ranging. To be honest, it's not possible to cover everything in the context of a 1 hour lecture, but we're going to look at a bunch of a wide range of past paper questions on the topics to try and deal with a lot of the key areas you may come across. Yeah, and as always, the lecture this will take the form of a lecture. I'll show on my screen, but if either of you have got questions at any point, you can either write it in the chat or it's no problem to put on your mic and ask. Please don't hesitate. I'm just going to share as well before I begin in the chat a couple of links. So the first link is to the YouTube playlist for this series. So this lecture is being recorded as always and will be uploaded to that playlist later. So it's a chance to watch this back and any previous lectures in the series. The second link is to the previous full running of a series, so it gives you the opportunity to go back to previous lectures if you wish, but equally it will give you the opportunity if it will give you the opportunity to move on to future lectures, but also it gives you the opportunity to watch like different versions of these lectures, and particularly on a topic like this, which is so wide ranging, we do tend to, from one course to the next, cover different areas. But to start with today, we're just going to look at a rather simple question about a graph, but to give some context to graphs in general. Okay. So you can see here we've got a picture of a graph, and we're just asked to write down the coordinates of point A, or write down the coordinates of points B on a grid that marked with a cross the points -2, 1. So basically, on any graph, on any graph or chart, the x-axis or x is across. I like to remember that an x is across, and the y is or goes down. Or if you're going to say this more technically, you could say the x is horizontal and the y is vertical. And whenever we write coordinates, we put them in alphabetical order, and so in other words, we have x before y. So here, for example, our question A is to write down the coordinates of point A. So we can see where A is on our graph up here. And if we look what it's in line with, it's in line with 2 on the x. We're told which is x, is y. We've got 2 on the x and 3 on the y. So we just put our coordinates in alphabetical order. So our x first, our y second. And so the coordinates for A is 2, 3. And then equally, we need to do the same for B. Well, B, as you can see, is on the y-axis. And what that means is for x equals 0. So we still do x first, y second. So it'd just be 0 minus 1. And then here we've got question C. We've got on the grid, mark with a cross the point -2, 1, label this point C. So now we just go, well, we know the first coordinates are x, we go to -2 in x, we go to 1 in y, and so we just put a cross there. We're told to mark it as C, and so job done. Now I'm just going to add a couple of questions here just to show a couple of things. So you could say question D, draw on the graph the line x equals 4. And so all this means is that the straight line will go through x equals 4, because it doesn't matter what y is. Our equation for the line is x equals 4. So if y equals 5, x equals 4. If y equals 0, x equals 4. Sorry, I don't have a straight line thing here. But you can see, so it goes through x equals 4 at all times. And then we'll add a part E here. So we're going to say draw a green line for x equals y. So again, it's a sort of basic line you might be given. It's still going to be a straight line. And what it means if x equals y, it means if x equals 1, y equals 1. If x equals 4, y equals 4, and so on. So how this will work out in the end, again, my line's not the straightest. You use a ruler if you're plotting this yourself. But it's going to be a straight line going through all of these points. Welcome, Putatana, as well. And so we carry on down. So if x equals -1, y equals -1, and so on. And it's just going to be a diagonal line through, which will be x equals y. But finally, I'm going to show here, we'll say, draw a yellow line for x equals -y. And so if you have x equals -y and negative in a graph, it's just going to do the opposite. So if you've got, as x goes up, y goes up, it's called a positive correlation. You're going to have a line sloping upwards. If x equals -y, it's just going to do the opposite. So it's going to go downwards. So it means like as x is -5, y is 5, x is 5, y is -5, and again you're just going to have this yellow line going through down here. So you can mark that as x equals -y. And in fact, I'm just going to make a little box in the corner just to explain just some correlations very quickly, because you might come across these three things in the exam. So as I said, it could be a straight line, but it could be a scatter graph with a mix of things. So this first graph here is a positive correlation. And what a positive correlation means is as x goes up, y goes up. You may be asked to recognize this in a question. Just a little line underneath to separate these. And then you could have down here You could have in the opposite direction, a bit like a yellow line on the graph, as I mentioned, which is a negative correlation, which is as x goes up, y goes down. All right, and then the third type you might get if you're asked to recognize the correlation on a graph. And you can see this is all over the place. And this is no correlation. And this just means no relation between the areas. Okay, so I'm just going to give a minute to finish either taking a screenshot or give a second to finish taking a screenshot, copy that down, and then we're going to move on to our next. Okay, sorry about this, just give me 1 sec. I thought I had it up here, but I don't. Okay, so the next thing we are going to look at is the equation of a straight line graph. And this is something you have to be familiar with in the exam. And it's y equals mx plus c. And it can be, it's a little bit of a confusing equation in ways because the m and c, I don't really know why they chose those letters. They could have made it easier, but it is how the equation is always written. And so you need to understand it. Now, the y and x should be relatively straightforward in this equation. So like the y just means number in y. The m equals, the m will come back to, so we'll put in the x here, which is just number in x. So what number y is or what number x is. So these will always just be replaced by numbers in the context of this. The other two will always stay the same. Welcome, Lynn, as well. All right, and then we've got our other two bits, which are the more complicated ones to remember. So m equals gradient. Gradient just means how steep the line is. And then C means y intercept, which is basically where the line, I'll explain these terms, but it's where the line goes through y on a graph. So I'm going to copy a graph down, a question on this, so we can explain things a bit clearer. So we've got here the question, we've got So like this can make it a bit smaller so we can slot it in here. In fact, we'll put it over here. So we've got find the equation of the straight line graph. And so here we've got to find two things to sort out the equation of a straight line graph. So to find out the equation of a straight line graph, we need to find out the gradient and the y-intercept, because x and y will just be written as the letters in the equation. All right, and so the y-intercept, it simply means the value of y when x equals 0, or where the line goes through the y-axis. So you don't need to do any calculations for this. We can just look at a line. Well, where does it go through the y-axis? It goes through it here. So in terms of our graph, we can say y equals, or sorry, I shouldn't say y, I should say c equals negative y. So the y-intercept, which of course is represented by the letter c, equals the value of y when x equals 0. So when the line goes through the y-axis, c equals -1. All right, and then we've got B, the more complicated bit, which is the gradient. And so gradient, or how steep the line is, it means in effect how much y goes up for every, how much y goes up every time x goes up 1. And so there's an equation for this we can use, and the equation is as follows. It is just simply, to calculate it, you do change in y divided by the change in x. And the way to work this out, you want to find 2 points on the graph we have given, and 2 points where x and y are whole numbers. So you could pick any of these, but let's pick these 2 points here. If I can, I'm always going to pick points where x and y are both positive, just because it makes the maths easier. So the change in y is simply between the 2 places. When our top point, y equals 3. In our bottom point, y equals 1. So it's 3 take 1. And then change in x between these 2 points, x just goes from 2 minus 1. So equals 2 over 1. And 2 over 1, whenever a fraction is over 1, you can just write it as an integer, so equals 2. So we know now, we know m equals 2. We know y equals c. And so our final equation would just be y equals 2m minus 1. Sorry, 2x minus 1. Sorry, my brain had multiple classes before this one. Even a coffee is not making my brain 100% here. But we've got y equals 2x minus 1. And to say for this, what this equation does, it means if you know the y coordinate, you know the x coordinate for anywhere on the graph, you can also put it into this equation and work out the y. So for example, if x equals 1, well, 2 times 1 equals 2, minus 1 gives us y equals 1, and we can see it goes through 1, 1. If x equals 0, well, 2 times 0 equals 0, minus 1 equals minus 1, and we can see the graph goes through 0, minus 1. If x equals 2, 2 times 2 equals 4, minus 1 equals 3, and we can see the graph goes through 2, 3, and so on. You could do it for anything. We can find out if x equals 10, well then 2 times 10 equals 20, minus 1 equals 19. So if x equals 10, y would equal 19. All right. And so, yeah, that equation, I would say it's reasonably important to understand it. You can get it in different contexts throughout the exam. You may be asked to write the coordinates for a graph. You might be given a table. So I'll give you an example of that actually, because I'd say it's the most common way it will come up. I'm just going to move to the next page in a sec. Okay, and by the way, if anyone ever needs me to go back a page, if you miss anything, please just let me know. Just put it in the comments, and I will, when there's a good pause, I will go back. It's not a problem at all. So now what we're going to look at, as I say, a couple more questions with y equals mx plus c. So for the following one, we will say plot the points for the graph, and you say y equals 4x, take 3 from x equals minus 3 to 3. And a question like this, we've got equation y equals 4x minus 3. It's from x equals minus 3 to 3, and you will probably be given a table. You won't be expected to draw it, but a table for something like this, look like this. You'd have x and y, and we'd have all of our coordinates here. So we've got so we've got a table here for that. And so to solve this, there's two ways you could do it. There's a long-winded way, but there's a simpler way. So we could solve this question by simply inputting the value for x into our formula for each coordinate. So I'll show you what I mean. E.g., if x equals minus 3, then we've got our equation here, so we can say y equals 4 times minus 3. And remember, whenever you've got a number and letter to give an algebra, it means multiplies. It's 4 times x, 4 times minus 3, take 3, and so 4 times 3 is 12, 4 times negative times a positive is a negative, so it would be negative 12, take 3, equals negative 15. So you could do this at every single stage, then do for x equals minus 2, minus 1, and so on. So that would be one way to work it out. However, we know that the gradient is 4, which means every time x goes up 1, y goes up 4. Equally, we know that y-intercept is negative 3, which means when x is 0, y equals minus 3. We can therefore use this info to simply fill our chart. Because we know, first of all, we can start with the y-intercept. Well, when x equals 0, y equals minus 3. That's what the y-intercept means. Well, obviously 4 times 0 minus 3 equals minus 3. And then we know, but what x is going to go up, y is going to go up 4 for every time x goes up 1. So if x equals 1, minus 3 plus 4 equals 1, plus 4 equals 5, plus 4 equals 9. In the other direction, we'd have to take 4. So minus 3 take 4 is minus 7, take 4 is negative 11, and if we took 4 again, we get to negative 15, which we'd already done. So you can use, as long as you understand the context of this equation, you can save yourself a lot of time plotting your graph. It can be useful in that way. But yeah, definitely worth practicing this all the way. So what I'm going to add as well here is I've just got another question here, if you bear with me. And so this is a question I've seen at the end of a GCSE, and it's basically just asking the same thing, but it's asking it in a different way. So it's actually quite a simple question for the end of the exam, but it would be easy to get confused. So we've got the equation of a straight line. L is y equals 3 minus 4x. Write down the gradient of L. So here we've got a straight line equation, but it's a bit jumbled up because normally we'd be in the form y equals mx plus c. And so if we're going to put it in that form, we would have y equals minus 4x plus 3. So I've just switched that round, so it's in this form. And now we just need to write the gradient of the line. Well, m is the gradient, so it would just be minus 4. Now we got down here, we got right down the coordinates to the point where L crosses the y-axis. Well, this just means the y-intercept, which is c within the context of our equation. So we know y equals 3, but we need to write down the coordinates. Well, whenever it's the y-intercept, x is going to equal 0. So your answer would just be 0, 3. So you can see a slightly different worded question. Can be a bit tricky for someone if they're not expecting it, but actually for late in the exam, as long as you understand the context, it's relatively straightforward. Okay, so what I'm going to just show briefly now is a question with 4 graphs, and this, as much as anything, is just to show you a different context of graphs, because you could be asked to plot a quadratic graph, which is a graph with x squared, or a cubic graph in the exam as well. So understanding what these graphs look like once you've plotted the points is important. So we got a question here. So we've got 4 graphs. I'll make it as big as I can. Sorry, it's not bigger, but we've got here, the diagram shows 4 graphs. So we've got graph A, graph B, graph C, and graph D. Okay, and so here, and we need to say which of these they are. So we've got y equals minus x. I'm going to write this on the other side as well because it's quite small. We've got y equals minus x cubed, y equals x cubed, y equals x squared, y equals 1 over x. So the first graph I'm going to mention equals y equals 1 over x. This is known as a reciprocal graph. And so you only need to recognize this for the foundation exam, although you could be asked to sketch it. And so y equals 1 over x is always going to be like graph A, which is 1 over x, a reciprocal graph. And that's what it means by reciprocal graph. So this type of graph creates two lines with a mirror image. All right. Image. And then, so we've got here as well, we've got y equals minus x cubed and y equals x cubed. Well, if I got a question like this in the exam and I wasn't quite sure, what could help me here to just use logic to work this out? Because if one graph is y equals x cubed and one is y equals minus x cubed, logically, they're going to be the opposites of each other. You just add a minus to a graph, they're going to be opposites. And we've got two graphs which are opposites of each other, which are graph C and B. And also, if it's positive, it's going to have a positive correlation. If it's negative, it's going to have a negative correlation. So we can look at our graphs here and be like, which one has a positive correlation? Well, that's graph C, which means as y goes up, x goes up, which has a negative correlation, graph B. And so we can look there. So you can say here, we'll just write a little note, cubic graphs. And so the cubic graphs are ones with x cubed, but these graphs always curves. You never draw straight lines, so don't join coordinates with straight lines. The curve always gets less steep around the origin. And what it means by the origin, this is a term you might come across with graphs, it just means 0, 0, so like the midpoint of a graph, so 0, 0, and will then get steeper again. And just to say as well, a negative graph does the opposite of a positive one with a negative correlation. And so cubic graphs are ones with y equals x cubed. And yeah, you could be asked to plot one of them in the exam. So it would just be a case of filling in the values for x, working out the coordinates, and then making sure you joined it with a curved line. And that leaves us with x squared, or one left, which is graph D. So we've got y, we're going to call it quadratic graphs. My quadratic graphs, one's like y equals x squared. Remember, a quadratic equation is one with squared. Quad, the prefix, it just means like something with four, just like a square, like a quad bike has four wheels, a quadrilateral has four sides. A quadratic graph is to do with x squared. Obviously, a square has four sides as well. And so quadratic graphs, these always curve back on themselves, creating a horseshoe, and that's because a negative number squared is the same as its positive number squared. So, for example, what I mean by that, e.g., you could say like 3 squared equals 9 because it's 3 times 3. and negative 3 squared also equals 9 because it's negative 3 times negative 3, and negative times a negative is a positive. So these always cut back into creating a horseshoe effect. And so you can see it there. Again, don't join coordinates with straight lines. If x is negative for horseshoe, we'll call it, that will be upside down. So yeah, just giving a little sketch here. If you had y equals negative x squared, it would look like the opposite of the graph there. All right. Okay, so hopefully that all makes sense. Gives a bit of a crash course in terms of graphs and areas like that. But what we're going to have a look at now, we're going to have a look at a few different types of different things in terms of graphs and charts we haven't yet seen. All right, so next graph we're going to look at here, and this is known as a conversion graph. Showing graphs. Exactly, and these are used to compare two measurements. And so in this case, it's money and hours worked. If we know one, we can use our graph to find the other. And so we've got how much money is Nazima paid for each hour she works. Now, graph's a bit small here. We could just go with 1 hour because it's reading off an hour and read off that. It's a little bit small. So I'm going to go to a place with a clear line, which is at 2 hours. If we follow across, it takes us to £30. So we can say 2 hours equals £30. And so to find 1 hour, you just do 30 divided by 2, which gives us 15. So she gets £15 an hour. And then we're asked, last week Nazima worked for 36 hours. How much money was she paid? Well, this is just actually a long multiplication question. We can do through 6 times 15. I happen to know it's 540, so I'm going to be lazy and do that, but you could just do a long multiplication if not. So she earns £540 in a week. Okay, so I would say conversion graphs in general are relatively straightforward compared to some other types you'll come across, but it's good to be familiar with them. All right, and so the next type of graph we're going to look at, a little bit different, is a distance and time graph. Okay, so here we got a question. We got Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. I need to work out speed of his travel. So basically, just to mention, one part of this won't be shown on this particular distance time graph, but distance time graphs show the relation between how far has been travelled and how long it has taken. So if someone is travelling away from the start point, the line goes up, as we can see here. If someone is stationary, so not moving, the line is flat or horizontal. And then this, I don't think it's on this particular question, but it happens if someone is returning home, the line goes back down. So say if it said, in this case, Sam then drove home, you would have a line which was the opposite of the one we can see. I'm going to cross this off, but you'd have a line. Say if it said he took 5 minutes to travel home, you would have a straight line down like this, back for 4 to 5 minutes. Okay, but in this particular question, we are just asked work out Sam's speed in kilometers per hour for the first 15 minutes of his journey. Well, I'll be honest, I wouldn't necessarily think of it in this way myself, but I'm going to mention the equation for speed, which is speed equals distance over time. Some of you may prefer to draw it as a triangle like this, which gives you all the equations, because distance equals speed times time, time equals distance divided by speed as well. And so the information we've got here, well, in the 15 minutes, so we know time t equals 15 mins, or 15 minutes being 1/4 of an hour. And remember, it's important this speed is always mentioned in, is always measured, unless you're told otherwise, in miles per hour, kilometers per hour. Then we've got distance equals, well, it's from 0 to 20 equals 20 kilometers. And so you could say speed equals 20 divided by 1/4, which is the same as saying if you've got 20 divided by 1/4, remember with fractions we can use keep, change, flip. And so it's the same as saying it equals 20 times 4, which gives us 80 kilometers per hour, which you can write in here. Exactly. If you can see the relation, you wouldn't have to write out all the equations, because you might just see that without really thinking about the equations. But if he's travelled 20 kilometers in 15 minutes and just times it by 4, so effectively do the same thing without all the work, and that'd be fine as well if you can just see that relation. And then we got part B. We are told at 10:15, Sam stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. On the grid, complete the travel graph of Sam's journey. Well, first, we've got he stopped for 10 minutes. Remember what I said, if someone is stationary, the line is flat or horizontal. We need to go from 10:15 to 10:25, and we can just draw a flat line between the two, which shows us that Sam is not moving. And then we're told he then drives 20 minutes at a speed of 75 kilometers per hour. So we're going to write this out with our equation. We can say 75 kilometers per hour. So the speed equals distance divided by 20, or 20, but it's 20 minutes. And so 20 minutes, we should convert this to. So, and what you could do if you're going for minutes, so you could say distance, um, distance equals speed times time, which is going to equal 75 times 20, 75 times 2 equals 150, equals 1,500, equals 1,500. But where we've got caused a problem here is we've done it within minutes. So this is what you've always got to be very careful of, and why you need to think of the context to it. So rather than traveling that far, what we should have done is we should have converted for 20 the amount of minutes, we should have converted it to hours. So we're going to put this in again, because if not, you'll get the wrong answer. And this is what you really need to be careful of on these questions, always making sure you are correctly between minutes and hours when you convert. So 20 mins equals 20 60ths, because that's 60 minutes of an hour, equals 1/3. So really it would be 1/3 here. So it would be equals 75 times 1/3, which again 1/3 is the same as equals 75 divided by 3 equals 25 kilometers. So always be really, really careful with that. Always make sure you convert into the best form possible between minutes and hours on any question with this. But in this case, we know now they're going to travel for 25 more kilometers. Well, 20 plus 25 takes us up to 45. We know they're traveling for 20 minutes, which would take us to 45 here, which means we are going to here. And so obviously you use a ruler in the exam, but you just draw a straight line between the two, and that will complete your graph. Exactly as Cardano said himself. Exactly. It is easier to convert to hours, and this is generally true for anything to do with time or anything like that. If you don't convert to hours, you're often making your life more complicated. Sometimes in a calculator paper it makes little difference, but the thing to really remember if you work with minutes and you need to convert to hours is, but that's 60 minutes in an hour. I know that sounds really, really obvious, but when you're dealing with an exam, so many students forget and convert by dividing by 100 instead of dividing by 60 between the two. If they're going from minutes out, so be really, really careful with that. With any questions, whether it's a graph or whether it's a general speed time question, always be very careful with that. Okay, so we're just going to introduce today a couple more different types of charts and areas like that. All right, so the next question we're going to look at is actually a stem and leaf chart, and we're going to use it to explain what a stem and leaf diagram is. These actually come up fairly regularly, I find, stem and leaf diagrams, so it's definitely worth mentioning. This is just a small 2-mark question. We're told a stem and leaf diagram below gives information about the ages of people in a social club. Find the range of these ages. So I just think a stem and leaf, it's a bit of a pointless diagram, to be honest. It's just a diagram invented by lazy people who don't want to write out all the data. But all a stem and leaf diagram involved is splitting a number up so the ones are separate to the other parts. And so we can see our key, it says 4, line 2 represents 42. And so a key for a stem and leaf diagram, a key for a stem and leaf diagram is always written like this. So taking a number, taking a line in the middle, putting like the full mark 2, 8 represents 42 years. It doesn't matter which number you take. So in effect, our top line of the stem and leaf diagram shows 3 results. And so 31, because you got the 3 and you got the 1, 34 and 35. So basically you have a line of data, the 3's from the tens column, the 1's from the ones between the numbers. You've got 31, 34, 35, 40, 42, 42, 45, 46, and so on. And the numbers in the stem and leaf diagram always go up from smallest to biggest. And here we are asked to find the range of all these ages. And so to find range just equals biggest minus smallest. So our biggest result, in this case, we've got a 7 and 4, so we've got 74 minus 31, and so that equals, we've got equals 43. Okay, just a little bit of quick revision. We're not going to work out for these numbers necessarily, but just to mention, because these will come up, so different averages. So you've got mean equals add up all the data and divide by the amount of data given. So e.g. in this case it would be like 31, 34, 35 and so on, and you would divide. We've got 8, 6 plus 6, we've got 14, 15, 16, 17, 18, we've got 19, 20. So e.g. in this case, you'd add all the data and divide by 20 as there are 20 different results. So that's the mean. Then you got the mode, and the mode just means the most popular, which data is the most of, and then you got the median, which is the number in the middle, if they are in chronological order. So you can work out the median by a couple of ways. You could put all the numbers in order, cross off ones at each end like this, so cross off 31, 74 and so on like that. Or if you have the numbers in order, if you add 1 to the total amount of data, so you do 20 add 1, and then you divide it by 2, that will show you which piece of data will be your middle number. And if your answer to that is a decimal, you'd add the 2 pieces of data either side and divide by 2. So it might be a little bit of a rushed explanation that here. So the range is the one we did for this question, Katana. So the range is just the biggest number minus the smallest number. So in this case, we've got 74. We can see it's the largest number in here. So let me show you how I've got that. So you've got the 7 plus the 4 from the graph, so the 74. we've got the smallest number, which is 31. We've got here, and it's just a gap between them, and that is what the range is. So the range is always whatever your biggest result is minus whatever the smallest result is. Okay, right. Okay, so I think actually what I'm gonna do, because there's not really anything um, to add within the time available about Russia, I'm actually going to leave it here for tonight. Hopefully that's okay. So yeah, unless any of you guys have got any questions. So yeah, thanks a lot to all of you for making it along. As I say, it's a large topic, graphs and charts, so you may want to look into it further, but a lot of the charts in particular, there's a lot of things we haven't covered, are fairly simplistic. So they're things you can practice yourself, and you should hopefully be able to get on top of. The graphs, it's just practicing more and more of the same thing, so that can work as well. But yeah, we're going to be back tomorrow, and tomorrow we are going to go through Pythagoras and trigonometry. So hopefully you guys can all make it, and I'll see you at 7:15 then. All right, have a good night, Katatana, Lynn, and Claire, and see you later. Bye bye.